Okay, this is problem number 3 from 2014 AP Problems. The first thing I notice when I look through these through A, B, C, and D is that they're going to ask for where the graphs are increasing, decreasing, concave up, concave down. So the first thing I'm doing is drawing this chart right here on my paper so I can refer to it just to have my answers there quickly. So the first problem says find g of 3. So g of 3, what is g defined to be? That's right here. It's the integral from -3 to x of the function f of t. So before we begin, let's write down one relationship. The derivative of g is equal to the function f of x. And that's a very important relationship you need to see before you begin, and it should be written somewhere in your problem. G of 3 is equal to the integral from -3 to 3 of f of t dt. So now I look up at my function. They give us a graph, and I can tell that everything can be found using geometry. So from -3 right here up until 3, I have this triangle, and I have this one right there. So the first triangle, so half of the base times the height, so that's half of 5 times the height of the triangle, which is 4, plus the area of the other triangle. Notice that it is negative, so I have to take that into account. Half of the base in this case would be 1/2 times the height of 2. So when I simplify this, I get 10 minus 1, which gives me 9. Okay, part B says on what open interval contained in -5 to 4 is the graph of g both increasing and concave down? Give a reason for your answer. So they're asking about the graph of g, meaning if I want to talk about where it's increasing and concave down, I want to analyze its first derivative, which is, we're looking at this part of the chart. So we know that the first derivative of g is equal to f of x. So I have the graph right here, and I can tell where it's positive, negative, 0, rising, falling, etc. In order to be increasing and concave down, rising, increasing, concave down, let me highlight both of those. I want to look at where this graph is positive and where the graph is falling or decreasing. So now looking at the graph, we are positive and decreasing right over here, and we are positive and decreasing again from 0 to 2. So when I write this out, I'm going to need a reason and where. So a point for the reason and a point for where. So part B. We can say that the graph of g, because they're asking about g, is increasing and concave down, you should write the words out, on the intervals. And now look back at the graph from -5 to -3. And we figured out it was also from 0 to 2. The reason is because, or since, g prime, which some of you like to write, which is also equal to f, is positive and decreasing on those intervals. Okay, that's part B. Okay, part C. The function h is defined by h of x equals g of x over 5x. Find h prime of 3, or the derivative of this function at 3. So step 1 is to derive h of x symbolically using what they give you. So we know we have a fraction, meaning we're going to use quotient rule. So part C, h prime of x is equal to, it's the bottom times the derivative of the top minus the top times the derivative of the bottom, which is just 5, all over bottom squared. We know 5x squared, I'm just going to rewrite that, is 25x squared. Now we're trying to find h prime of 3. So we plug 3 in for x. 5 times 3. G prime of 3, we know f is g prime of 3, so we go to 3 on the graph. We know when we go to 3 on the graph, we get negative 2. So times negative 2 minus g of 3, we already found in part A, and we got 9. So minus 9 times 5, all divided by, when we plug 3 in, 3 squared is 9 times 25, we get 225 on the bottom. And when we simplify this all the way, you're going to get negative 1 over 3. So here you have a point for finding, 2 points for finding the derivative over here, and 1 point for being able to plug things in and find an answer. Okay. Part D. The function p is defined by p of x equals f of x squared minus x. Find the slope of the tangent line to the graph of p, where the point where x equals negative 1. So slope, we're finding the derivative of p of x. So part D, to find p of x, think of what derivative rules apply. You have a function within a function, it's composition, so we're using chain rule. So step 1 is the derivative of the outer function times the derivative of the inner function, which is 2x minus 1. Now we're looking for the slope at x equals negative 1. So we're finding negative 1 squared is positive 1 minus negative 1. We know that is 2 times 2 times negative 1 is negative 2 minus 1 is negative 3. Okay, simplifying. So we know that f prime of 2 is the derivative at a point on this graph. So I go to 2, which is right here. I notice, oh, that's just a line. So we're looking at the slope of that line, and the slope of that line is negative 2. So our final answer becomes positive 6. 2 points for finding this derivative, 1 point for actually plugging things in correctly. And that's it.